Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. When a molecule contains both an alkene and a hydroxyl group, treatment with Br2 can lead to intramolecular cyclization if the geometry is favorable, forming a cyclic bromonium intermediate that is then trapped intramolecularly by the hydroxyl group rather than by bromide ion. Moving on to the next step. The starting material is 2-methylene-7-heptanol or equivalently 2-methylene-heptane-1-ol depending on numbering. It has a terminal alkene, CH2 is equal to C, CH3, at one end and a primary alcohol, CH2O, at the other end of a 6-carbon chain. Moving on to the next step. Bromine reacts with the alkene to form a bromonium ion intermediate. Br2 attacks the electron-rich double bond to give a cyclic bromonium ion at the alkene carbons. And for the final step. From the bromonium ion carbon to the oxygen of the OH group, there are enough atoms to form a favorable ring. The hydroxyl oxygen can act as an internal nucleophile attacking the bromonium ion carbon in an anti-fashion. Counting the chain, OCCCCCC, bromonium, gives a 6-membered ring transition state, tetrahydropyrin ring, which is highly favorable. The oxygen attacks the more substituted carbon of the bromonium ion, Markovnikov-like intramolecular attack, displacing bromide and forming a 6-membered cyclic ether, tetrahydropyrin. The methyl group and a CH2Br group end up on the same carbon, C2 of the ring, which bears the oxygen, giving a 2-methyl-2-bromomethyl, tetrahydropyrin. This matches option C, a tetrahydropyrin ring with a methyl group and a CH2Br group on the carbon bearing the oxygen. Why other options fail? A and D, simple addition of Br2 across the double bond without cyclization. This would require the intramolecular OH nucleophile to be ignored, which is not the case given the favorable 6-membered ring geometry. B, gemdibromide formation is not expected from simple alkene plus Br2. This would require a different mechanism. Therefore, the correct answer is C. Therefore, the correct answer is option C.